Hi, my name is Guillermo and our team is Ruby, Diego, and Marco. And today we'll be learning about differential calculus and its applications in physics. Let's go. Differential calculus is an area of calculus that focuses on the rate of change of one quantity with respect to another. Or you can also consider it as the study of rates of changes of quantity. For example, one thing that differential calculus deals with is velocity, because velocity is the rate of change of distance with respect to time in a particular direction. That's just one of the many examples of formulas that differential calculus deals with.
We have seen that differential calculus can be used to determine the stationary points of functions. In order to sketch their graph, calculating stationary points also lends itself to solving of problems that require some variable to be maximized or minimized. These are referred to as optimization problems.
For example, the fuel used by a car is defined by this equation, where b is the traveling speed in kilometers per hour. What is the most economical speed of the car? Well, in other words, determine the speed of the car which uses the less amount of fuel. If we draw the graph of this function, we find that the graph has a minimum. The speed at the minimum will then give the most economical speed. We have seen that the coordinates of the turning point can be calculated by differentiating the function and finding the x-coordinate, speed in the case of that sample, for which the derivative is 0. We have seen that the coordinates of the turning point can be calculated by differentiating the function and finding speed in the case of that sample, for which the derivative is 0. If we set the derivative of x b equals 0, we can calculate the speed that corresponds to the turning point. This means that the most economical speed is 80 kilometers per hour.
Calculus is of vital importance in physics. Many physical processes are described by equations involving derivatives, called differential equations. Physics is particularly concerned with the way quantities change and develop over time, and the concept of the time derivative, the rate of change over time, is essential for the precise definition of several important concepts. In particular, the time derivatives of an object position are significant in Newtonian physics. Velocity is the derivative of an object's displacement. Acceleration is the derivative of an object velocity that is the second derivative of an object position.